Hello and welcome to another video, and in this one we're gonna take a look at adding shadows to our ray tracer, optimizing it a little bit so it's has quicker render times, and as well as adding a checkerboard shader, as you can see here. So this is what we're gonna try to be our end product at the end of this video. So let's get started. So this is what we have currently, but there's two things that we need to look at or fix rather. Um, First is where we check for the nearest distance. So there's like two bugs that we need to fix. Right now it's not much of an issue, but when we work on adding shadows, that'll be a problem. So right here where if we check if our nearest distance is less than t, we also need to do if nearest distance is less than t or t is less than 0. So that's the first thing. So basically right there we say skip if not the nearest or behind the origin. So that's good. Next, we're gonna go down here or to our spheres, um, where we calculate the first solution to the quadratic equation and the second solution. We need to divide it by 2. So let's just do that real quick, both of them. Let's see. All right, there we go. So now that's fixed. So the two things are fixed. So the next thing to focus on then is we're gonna figure out how long it takes for us to render, and we're gonna try to optimize that. So, one second. Alright, yeah, that was messed up. Okay. So we're gonna go ahead and comment this out, and we're gonna put right here, let's start. And then we're gonna use JavaScript's date function, and then we'll get like in milliseconds how long it took for us to render it. So you go here, and then now we just call our render function without set timeout. Then we'll just say after that's done, it's out of that function. We'll call it the date function again and get the time it took. And then we're just going to console.log this as we're going to do end minus start. And let's go take a look at our code. We're going to right click, inspect, and we should be able to see here. So it took us that long. So one thing that I would like to do is push the sphere back a little. So I'm going to go up here where we set up our spheres. Uh, Instead of negative 1.45, I'm going to make it negative 1.8. Let's see what this does. That's nice. But then I want to move our left triangle a bit as well. So I'm going to go here. I think make this 1.5. Move that back as well so you have like a nice intersection. Yep. All right, perfect. That's what I was trying to go for. We'll further adjust the left triangle, the green one, more so we can get some more interesting shadows. But right now, this is good. That obviously put down the rendering time, but that's not why we did that. It's more just for us trying to show the shadows. But let's go back, get back to making it more optimized. So first thing, we don't need this currently. If we do, we can always add it back. I'm just gonna comment it out, and then the biggest thing that's going to save us a lot of time is right here. We just always just make the whole thing black, but instead we're just going to do it here instead if there's no result. So we're just going to make an else statement. If there's no result, then we're going to go ahead and make the pixel black. So let's see. Got 541. Now it goes down to 375, 348. Nice. So that's pretty good. Another one we're going to do is the first bug fix that we did. We're going to copy this and we're gonna move it. This is not gonna be as big of a difference, but still pretty good. We're gonna do it right after we get our T. That way we're not going through all this process that's taking up time, like getting the cross product and stuff. So go back here. First one's always takes, I guess, longer, and after that, see, not as big a difference, but it's pretty optimized now. So that's pretty good. So we're pretty much done with the optimization section, uh, which means then we can move on to adding shadows. So we're gonna go to our calculate color function right here, and then right below this, where we go through the light specs, we're gonna say, you know, if I'm in a shadow, then abort. Otherwise, calculate the contribution of this light source. So we're gonna do let result equals, we're gonna call our cast array function. We're gonna pass in p, and then the light spec dot light direction. So let's go ahead and see what this does for us. Not quite. Alright, light spec. Oh yeah, okay. Forgot to add if result continue. Yes. Okay. So yep. Let's go take a look at what this does for us. There we go. So now we got some shadows, but it's very specular. Um, so that's not great. So but it's a start. So let's go back to our code. What we're gonna do is we're gonna add the light direction. We're gonna get the light direction, which is let R equals light spec dot light direction. That's what we should do. Light spec dot light direction. So when we call the cast array function, we just pass in the O and R just like that. That's kind of the goal here. So next we're gonna get the O. What we're gonna do is let P or let O equal, you can set it to P, but that's just the same as, I guess, so you can just do this. Oh, okay. Alright. So now this should just work the same way, but we still need to modify it so it's not that specular. So I'm just gonna take this P off. Instead, we're gonna use the add function, then put P in, and then we're gonna scale the R. And so basically what we're doing here is we're offsetting the origin slightly to avoid the self intersection. So we're gonna do point, and you can do like um, 5 zeros, 1. Then we go here. Now we should be able to get our nice shadow. There we go. We get our shadow, and it's not specular. So that's great. Obviously, it takes longer to render now, and this is perfect. So now that we got that going, we have, shadows. Next, we can work on adding more light sources to make the scene more interesting. So we're just gonna copy this light spec that we have here to light spec 2. We're gonna change the direction of this. So our current light, um, okay, our current line is just from here, and it's we go -1, so it's from here. It's the light sources. We're gonna add another light and also change up the color. So we're gonna go -1, -1. So now our light source should be -1, -1. So coming up from like this bottom corner. Um, but then we're gonna change up the color of the light. Instead of just being the white light, we're gonna make this one a bluish light. 0.2, and this needs to be 0.5. Okay. Then we need to add it to our lights array. There we go. So let's hopefully we go see, and yeah, there it is. You can't really see the bluish, but you can see the, the light direction and the shadow it's creating, which is pretty nice. We got more shadows. Um, Makes the scene more interesting. And then we can go ahead and add another light source as well. Call this light spec 3. And we're going to make this one um, red. And also, it's going to be, one second. I forgot to change the name. All right, there we go. So let's make it red. 0.8, 0.5, 0.5. Right. So this one should be coming up -1 and 1, so somewhere up there. And one thing that I did forget to do is normalize the direction. Let's go ahead and do that. All right. So the light direction is now normalized, and if we go, we should be able to. Oh, okay. I did not call it in the lights in our light array, so I did not set it here. There we go. Now we should be able to see it. Yes. Just refresh. Yep. There we go. So now you can see that reddish light, which is pretty nice. And we have more shadows. So we have a light from here, a bluish light from down here, and then a reddish light from up here. Pretty nice. We got a nice, much more interesting scene now. And one thing that we can do is I'm gonna change up the left sphere a little bit so we can get more interesting shadows. So that green triangle we have. Um, so that should be good. Let's go check it out. Ah, there we go. So you got that nice reddish light. We got our shadows here. We got this shadow right here. Pretty nice. I know it's a little funky, uh, but yeah, that kind of gives you the idea how it's working. Let's see our render time. Taking about that long. Pretty nice. All right, now that we did that, uh, the next thing to do is we're gonna, in order for us to have more interesting shaders, we need to change up our uh, calculate color function. So let's go ahead and do that. So what we're gonna do is currently we're just passing in all these parameters. Instead, we're just gonna get it from our result. So I'm gonna delete all of this, and then we're just gonna pass in the result. And from that, we should be able to get everything that we need. So first is let n equal result dot n, which is the normal at the intersection point. Next, we'll get the p, which is result dot p. This is the position of the intersection point. Then we can get our diffuse color, which is just result dot spec dot color. But this is gonna be modified in a bit here. Then we're gonna do double-sided equals true. So this is whether the object is double-sided or not. That's where we check that. But this is not gonna work because we need to go down here to our render function. Just pass in the result. And hopefully this just works after we did that. All right, perfect. So this is great. So now we can add more interesting shaders. So what we're gonna add is we're gonna make a checker shader. So let's go to Blender so I can showcase that real quick. We're gonna delete this. We're gonna do it for our sphere. So mesh UV sphere, nice. And then we go here. We're gonna add a material, and then right here if it loads. Okay, we're gonna click on this and checker texture, and we'll go here. Perfect. So this is what we're gonna try to add to our sphere, because if you see currently it's just a plain sphere. So this will be a lot more interesting. So we're gonna do that. But in order to do that, we need to change up how we have our colors set up on our triangles and spheres. We need to make it a function. So what we're gonna do is we're gonna change this to be called diffuse shader. Then we're gonna make it function like that. Diffuse shader. There we go. Change this to that as well. Diffuse shader. So this will allow us to get more interesting, or add more shaders instead of um, just, passing the base color. So then we need to change this here. We need to, instead of getting the color, we need to be getting the diffuse shader. And hopefully when this shouldn't mess, should just work fine. Yep, great. So now that that's fixed, we're gonna go ahead and make our um, checker shader function. So we're gonna call it function. So checker shader. Right. There we go. So, and this is for the sphere. We're gonna focus on getting this checker shader for our sphere. All right. So let's work on adding that checkerboard. So let's go to our code. We have our checker shader, but then we're gonna first get it so it just works normally. Let's see. Okay, 1 second. I need to go here. We need to call. We're just gonna replace this with our checker shader function. Let's see. It should just work. 1 second. Here. I think I need to delete these parentheses. Is that it? Yep, that should be it. Perfect. So now it just works like, like how it was. Now we need to do the calculation to be able to do the checker pattern. So first thing is we're gonna check if result dot py is greater than 0. If so, then I'm gonna have you return yellow. If not, thinking else, then I'm gonna have you return black. And let's see what this does for us. Let's see, we have an average shader. It's diffuse shader. Is that so? What's the issue? Let's see. Diffuse shader, pass that in. Result dot spec. Alright. The issue is I don't pass in result. Um, you know, the intersection result. So now it should just work. Yep. Ooh, okay, I guess I ended up doing right. So there you can see, we got half of our sphere white, and we got the other half yellow. So that's a start. So let's go back to our code. Now instead, let's need to change up how we calculate this. Let's try setting up this. Instead of doing result.py is greater than 0, we're going to do result.py equals result dot px. So let's see what this does for us. Oh, okay. I think we're not. Let me change the color. Let me just make this black instead of white. I think it'll be easier to see our changes as we go. Ah, okay. So now the whole sphere is black, and then here you can kind of see it's kind of that checkerboard-ish. It's trying to do that. It's not ideal. So we tried that. The next thing we're gonna do is we're just gonna set our px here to result dot px dot py. Now we can modify these values to better suit the checkerboard pattern. So py. All right. So now this should just work the same way. All right. Now we're gonna do a math.floor function on it, and let's see what that does for us on both these px and py. See, now we can modify these, and that will, give us some leeway. All right, let's go here. We'll just refresh. All right, so it's a kind of got that checkerboard where we kind of have it like split like this. So it's a next step. Um, now we're gonna multiply this value by 2, and let's see what that does for us. Now you can kind of see there's like black checkerboard right there. Okay, now let's multiply it by a bigger value, like 10. Let's see, go here. Oh, okay, so now we kind of have that checkerboardish um, pattern, but then obviously just like one way. Before it was very shrinked, if you remember, but now it's bigger and like a checkerboard like we want. Um, what we're gonna do is we're gonna do modulo 2 both of these, and let's see what this does. All right, this the closest we ever got. So in this quadrant and this quadrant, you can kind of see that's pretty much what we're trying to go for, but it doesn't quite work out on these two quadrants. So the final thing to do is math dot absolute. Take an absolute value of this and do that for this as well. And let's see if we achieve. It just needs to refresh. There we go. We got our checkerboard pattern. Pretty nice. And we still got our shadows here. We got our shadows here. Got this shadow. Got that reddish light coming from the top left corner. Got that. You can kind of see that bluish tint on it, coming from the bottom corner. And yeah, that's so we have added shadows and a interesting shader. And not only that, our code is running a lot more optimized now. And we have set it up so we can add more shaders and do more interesting scenes in the next time. So that's it for the ray tracer. But I would like to, before we close off, I'd like to quickly show something in Blender because a lot of people are still working on um, the Blender section, and the last thing they have is adding a animation with bones. So we're gonna come in and we're gonna start a new one. This is because that's like the last part people have left. So I think some people had questions was that how do you keyframe bones? Because I think it's not as straightforward as how we keyframed other objects. So I'm gonna go ahead and try to delete this and then Shift A. We're gonna pop in a bone here. Then we're gonna go to edit mode. We're gonna make another bone. Click on E, Z axis, extract. We got another bone. Pull up our timeline here. Then go into pose mode. So Now what we're gonna do. All right. So in order for the keyframes to work correctly, you need to click on bone. And here, once you do that, select this bone. We're gonna press I just like how we do for normal keyframing. So that has set that right there. We're gonna go to like 80, not even that much, like 40, just to showcase. And then use the same principles as we do, move to the time, then make the changes. And press I. And there you go. We start from 0, just play it out. You can see that change, and then we can go to like 60. So like this, rotate it even further. Press I. If it wants to. Ah, there we go. Just being weird. Okay, let's play it out. All right, perfect. So that's how you add, keyframing to bones. Go into pose mode, select the bone tab here, and yeah, and then you can kind of see how it reflects the changes, like how it does with other objects when we do it without bones. So yeah, that's it for this video. Um, I hope uh, this was helpful to know how to add shadows and then adding a checkerboard shader, as well as for the people that are looking to still add their bone animation. So thank you.